Thank you. So today I'm going to talk about how to boost your LLM AI applications with a scalable, highly scalable SQL relational vector database, and we are building it at MyScale. I think most people here have heard about vector databases. So nowadays, large language models together with vector databases are driving a new wave of applications. You can use them to help you write code. You can chat with a website, analyze financial documents, and a lot of other things. So in all these cases, basically, vector database allow you to connect the large language model with your data or customer data to deliver better results, such as higher accuracy and more relevant results. Because of the rising needs, recently we have seen a surge of such products. For example, we have the specialized vector databases, such as Pinecone, Fusion, Milvus, and VV8. Some of them are here. And so these products are specially designed and optimized for vector search, so their performance is usually pretty good. And recently, the traditional data systems are also adding vectors, such as OpenSearch and Elasticsearch are adding vector search to their keyword search APIs. And SQL is still the most widely used data language to talk to data. And PostgreSQL and ClickHouse are also adding vector search to their SQL API. However, compared to the specialized vector databases, the vector search performance and accuracy of such systems is usually not as good. So is there a product that combines the best of both worlds? So that is MyScale. So MyScale provides full SQL support. So you can manage SQL and vector in one integrated system. And it achieves higher vector search scalability and performance, even compared to the specialized vector databases. And you can sign up today at myscale.com and get one free pod supporting 5 million vectors. Oh, that's the most generous offer you will get on such services. And you can do POCs and everything, yeah. So there are several reasons that you should consider MyScale. The first reason is it allows you to manage and query all your AI-related data in one place. So either they are structured, text, JSON, geographics, vectors, and more. You can do them in one system, so very convenient and efficient. The second is that the SQL interface is very powerful and widely used. So it supports complex queries. For example, you can do semantic search on the movies, and then you can join on the rating table to return only the results with high ratings. What's even better, because the LLMs know the SQL very well, so it can translate from text to SQL for you. So you or the end user doesn't need to write SQL, or they don't need to know SQL. You can just write simple plain text. And a large language model can translate from text to SQL and vector for you. It also connects with existing data systems, such as transactional database, streaming systems, and data lakes. The connectors are very easy to use. And also, it has powerful and time-tested role-based access control protocols. And the second reason that you should consider MyScale is that it provides higher scalability at lower cost. So it outperforms the specialized vector databases. So for example, compared to the Pinecone P2 pod, when managing 5 million data, we can provide similar performance at a fraction of the cost, just one-fourth of the cost. And also, by combining advanced vector algorithms with a fast columnar SQL execution engine, we achieve even better metadata filtering search. So you first search on the filter on the structured data, then perform the filter vector search. And in this case, our performance is even higher. So it achieves like similar faster performance at a fraction of cost. It's 4 times to 5 times more cost efficient than the alternative. So at the same price, you can put 5 times more data into our database. We have also done extensive testing compared to other database services, and it's fully reproducible, open source online. You can check the results if you want to compare different services. In every case, like we do much better. So given these advantages, like how to use MyScale to achieve like your applications, to design better applications, let me show you several examples. In the first case, with MyScale's assistance, a major research institute has launched a QA system comprising millions of research papers. So it empowers the researchers to gain profound insights into different fields. So in this case, because they have millions of papers and hundreds of millions of vectors, they need complex queries involving both structured data and vector data, such as category, the authors and years and such. And the search latency and the upload time by using MyScale is reduced by 4x, and the overall cost saving about 3.7x compared with the best alternative. So inspired by this idea, we have also done an open source Hugging Face chat data app. And we have put all the about 2 million archive paper, title, and abstract into the database. And you can do like fancy queries, such as you can ask the database, did Geoffrey Hinton write paper about capsule networks? So the paper should be about capsule network, and Hinton should be in the author list. Or you can ask the database to introduce some applications of GANs published in February 2019. So here you specify the published time should be February 2019. Let me give you an example. You ask in simple English. So the language model, given the table schema, can translate your query into a vector SQL query. And then it retrieves rated context from the database and then synthesizes the result. So then you get the result in plain English. And also, we have contributed this test to SQL and advanced self-query into Linpeng. So I think a lot of you have used Linpeng, so you can check us out and use these like integrations. And the second use case is that MyScale provides each user with a long-term memory with a popular chat app. Like companion apps driven by LLMs are really popular nowadays. And here the customer, they have a similar interface to Character AI, and they want each of their users have a unique long-term memory when interacting with their virtual characters. So, and this is actually behind the scene, it is supported by a large-scale multi-tenancy vector search in MyScale. And in MyScale, it's supported through data partitions and primary keys. So first, we partition by the hash value of the user ID. And then within each partition, we order the data by user ID, message ID. So you have better data locality, and you have better search performance. So this is an illustration. You have like hundreds of partitions, and each partition, you order data by user ID. So, and in vector database, SQL database is infeasible to have millions of data partitions, right? It's infeasible if you want to do a search across multiple partitions. So here we basically do a two-dimensional partitioning, like first partition on the first partition by user ID, and then using each partition, we basically use a high-performance metadata filter search to solve the large-scale multi-tenancy problem. And the third use case is all very interesting, that you can supercharge your large language model with a large knowledge base, such as Wikipedia. So we have done an open source project that by combining GPT 3.5 or Llama 2 13B with the Wikipedia, that's about 36 million paragraphs and about 28 billion parameters in the vectors. So the number of parameters in the vectors is actually larger than the 13B model, right? And what can we achieve? We can boost the MLU score by up to 9 to 15%. So that's a big improvement, right? And here, instead of when the user asks a question, instead of directly going to the large language model, you can first transform the question into a query into a database, get the related paragraphs from Wikipedia, and then you can ask LLM with the external knowledge enabled. And here is an interesting result, So the retrieval augmented generation can reduce hallucination and greatly improve the accuracy even when Wikipedia is already in the training set of these large language models. So all the large language models has been trained on Wikipedia. But because the transformer model cannot remember all the details, so this large-scale RAG helps it record the facts and improve reasoning. Let me also do a cost breakdown analysis in such case. So if you host a Llama 2 13B model with a Wikipedia knowledge base, so like one of our typical users, they want to support like 100 concurrent users. So they need like 5 H100 GPU, and it costs you about $14,000 per month. And if you host a Wikipedia 2 replica with MyScale, it costs you about $2,000 per month. So this large-scale retrieval augmented generation can greatly improve performance while incurring less than 15% additional database cost. And because the database is very performant, you can even have more users, so the amortized cost will be even lower. And MyScale's cost efficiency makes this large-scale retrieval augmented generation much more scalable. So if you use other database products, it can easily cost you about $10,000 per month. So that's very expensive. So we are also very interested in like exploring this approach where you can combine a medium, customizable, open source language model with a relatively large knowledge base, where you can greatly improve your results while maintaining the cost manageable and fully customizable for your app. So this has recently also go open source and online. You can also check out Hugging Face MyScale, and there is a chat data app where you can use both the archive paper as a database or the Wikipedia as a database, and you can check it out. So what about the future? So in the future, we envision a LLM and data stack, right, where you can put all your data into MyScale, structured text, vectors, JSON, and logs, and everything. And MyScale can do very efficient and scalable data management and semantic retrieval for you. With these capabilities, you can enhance the knowledge of your large language models. You can do caching to reduce cost. You can log all the user feedbacks and generate tags. So you can do data analytics to further improve your apps, your application. And with all the data, you can fine-tune your model and further improve the result. So in this case, integrating large language model with a scalable relational vector database can improve performance, reduce cost, and what's more, it brings greater value by combining customer data or your data, building a virtuous value cycle. So in the end, I think you deliver greater user value, and you are more successful. Thank you. Yeah. Questions?
Hello, thank you for the sharing. I have 2 questions. One is like, how do you deal with the data privacy and security in MyScale?
Okay, so currently, so we have a SaaS version, MyScale.com. Is hosted on AWS, and we are SOC2 compliant. And we have we have also a blog about how do we like run MyScale on AWS. If you're interested to have fully security, and also if you want higher security, we can also do on-premise or BIOC, bring your own cloud. So we have different versions. Yeah.
Okay. The second question is like you're using large language model to turn my natural language searching into a query.
Yeah.
And I know sometimes if your query is like, if your search is very complicated, the language model can get it wrong. Did you do some kind of post-processing to make sure that it doesn't go wrong?
Oh, there are 2 steps. The first that you need to transform from the user query, like into a user question into a database query, right? So given all the context and the current question, you can transform into either like self-query, they call it self-query, or you can do text to SQL, you can do both. and then you get back results, and then to make sure everything is safe and correct, you also do like post-processing to filter out the bad results. So you do those steps, like 2 or 3 steps. Yeah.
Hello. My question is regarding the first use case where there were a lot of papers, hundreds of thousands of papers, I guess.
Yeah.
Sorry. In that use case, was a LLM used, or was it only vector search from MyScale database to retrieve the chat results?
So yes, LLM is used always. So in the case, we put basically the title and the abstract of the 2 million archive papers, and you ask in English, and your English question will be translated into a SQL query. So that part is always, we always involve a large language model. And then you can just return and render the results, and then furthermore, you don't use a language model. But if you want to return the results in English paragraphs, then you synthesize the result, like using the retrieval augmented generation approach. Yeah, prompt engineering. Yeah.